Hello, everybody. This is the review for the second lesson in optics, which was on October 30th, 2019. Unfortunately, the handout still says October 29th. That was my bad. But okay, we're going to talk about the important concepts that we covered in class today. So the first thing we talked about is what a control is. So we used the example of a drug trial to establish what a control is, and we also used the control that Herschel himself used. So control is a group of people or an experimental condition that have everything the same as what you're testing, except the variable that you are testing for. So again, this is always better, I find, explained with an example. So we're going to again consider this one person with a tummy ache or stomach pain. Say that, sure. Oh my god. Never mind. Sorry about that. Stomach pain, and then we give him some medicine, and then he gets better, but we don't know whether the medicine caused him to actually get better or whether it was because of some other condition. Like we said, maybe he started eating healthy or sleeping better, and therefore his stomach pain went away, right? So we don't know whether it was the medicine that cured his stomach pain. So what we should do for a proper scientific experiment is have two people with stomach pain and then have all the other conditions that they experience the same. So they eat the same thing, they sleep the same way. So all the other conditions, all the other variables that could affect their health are the same for these two people, except the fact that one of them is given medicine and one of them is given what is called a placebo, which looks like medicine but is not actually medicine. If the medicine actually works, only this person will get better, but this person should still have a tummy ache, a stomach ache. Does that make sense? So in Herschel's experiment, let's erase all of this. In Herschel's experiment, the control would have been a thermometer that is placed in the room that did not come into contact with any kind of light, right? Because he wanted to test, so his variable, he wanted to test how colors of light, how they affected temperature. So he wanted to see what the effect of colors on temperature was. So he hypothesized that a violet color would have a different temperature than red color. So his control would have been to set up a thermometer with all the same conditions. So it was in the same room, it was very close by, so that not half of the room was hot and half the room was cold. So very close by the other thermometers, but there was no light or no color on this control thermometer. So that would have been a good control for him to set up. And he did, in fact, set that control up. So that as long as you understand what a control is and can explain it using a good example, that's all you need to know for a test. That's probably not going to be on a test, so don't worry. This Herschel's experiment is kind of important. The important things that you have to know are split white light into component colors using a glass prism. This was his hypothesis. He hypothesized that different colors had different amounts of heat or different temperatures. So he set up thermometers for each color of the spectrum. He noticed that red light had more heat than violet light, or was hotter than violet light. That is his observation. All right? However, a thermometer beyond the red light had an even higher temperature, and inadvertently he had discovered that there were parts of the spectrum that we cannot see, and he had measured the temperature of infrared rays, right? His control was the thermometer he placed beyond the red spectrum, but that didn't really work out because his control should have been lower, and because the light was shining on the other thermometers should have had more heat, but his control had a higher temperature, which led him to discover the infrared rays. So that's an interesting bit that he did there. Most of this is not really important. I won't be asking you to, none of this is actually directly what the purpose of this entire activity, and I'm sorry if you missed the activity in class, is to understand. So this is important. This paragraph right here, very, very important, right? As frequency increases, wavelength decreases. That's right here. So this is called inverse proportion. That means as one goes up, the other goes down, and vice versa, right? As wavelength increases, the frequency would decrease. But the frequency and the wavelength, if we multiply them together, we get the speed. All right, so that's important because as we saw here in this little example, 3 cycles or 20 students was our wavelength, so 0.05 was our frequency. We multiplied them together, we got 1. As our wavelength went down, as our circle got smaller to 10 was our wavelength, our frequency got bigger from 0.05 to 0.1. But when you multiplied them, they still gave you the same answer as 1 meters per second of speed, right? So, for example, radio waves have the longest wavelength and smallest frequency. Gamma rays have shortest wavelength and longest or highest frequency. But both radio waves and gamma rays have the same speed, which is the speed of an EM wave in vacuum, 300 million meters per second. Right? We also, I haven't had answers for this. Units of wavelength. Wavelength is a distance, so it's measured in meters. Frequency is measured in inverse second, so it's the something per second, right? It's the number of cycles per second. That's also actually important. What is the definition of frequency? Definition of frequency is number of cycles per second. And we multiplied a wavelength and frequency together, and the speed unit was meters per second. 1/second can also be written as hertz. So Hertz is a scientist who discovered or who did some important work relating to these kinds of concepts, so we named the unit after him, hertz. So hertz is equal to 1/second. They mean the same thing. All right. Okay. I mean, this stuff, I don't really know if I should talk about it. Some things are luminous, which means they make or produce their own light. Some things are non-luminous, which means they reflect light from other things, and we can come up with examples for both luminous and non-luminous objects. We stopped here today where different types of waves do different things when they hit the same object, and that's because they're different types because of their different wavelengths, right? So I realize I'm already over time. I try to limit these videos to about 8 minutes, hopefully 5 minutes, but I'm already 3 minutes over time. That's my bad. We will continue with this worksheet in the next class. All right, peace.